can start. So good morning and welcome to the ceremony awarding the 2018 Raymond and Beverly Sackler International Prize in the Physical Sciences. This year the prize is awarded in physics in the field of quantum field theory, novel developments and application to Professor Zohar Kumargotsky from the Weizmann Institute, Israel, and the Simon Center for Gravity and Physics, the United States, and to Professor Pedro Vieira from the Perimeter Institute, Canada, and the International Center for Theoretical Physics, SAIFR, in Brazil, for outstanding work probing quantum field theory in non-perturbative regimes. The Sackler International Prize in the Physical Sciences was established in the year 2000 through the generosity of Dr. Raymond and Mrs. Beverly Sackler, visionary patron and devoted friends of Tel Aviv University, and chairman and distinguished member of the Board of Governors of our university for many years, actually since 1972. The prize alternates each year between physics and chemistry. It is intended to promote and honor originality, creativity, and excellence in research of young scientists under the age of 40 in theory and 45 in experiment, who made outstanding and fundamental contributions in their research field. I believe that when this prize was established, it was the first prize that really catered in an international way to young and leading scientists. The prize is administered by Tel Aviv University through a steering committee who approves every year the field among those suggested by members of the School of Physics or the School of Chemistry. Once the field is chosen, an ad hoc coordinator or coordinators are appointed, and they are in charge of the selection procedure through an international call for nominations and a particularly strong ad hoc appointed international selection committee whose members are prominent and leading scientists in the chosen field. This year's ceremony is particularly special on three accounts. First, it is the 18th year that the prize is awarded. Now you know that in Hebrew we assign to every letter a number, and 18 is the famous word chai, which means alive. And indeed, the prize, we see that the prize is alive and kicking. Through the excellent choices made over the years, the prize has gained a very prestigious and respected stature. And we have seen it by the really big numbers of nominations by very prominent people that we have received. Almost all laureates continued to be among the leaders in their respective fields and gained also later on other prestigious prizes and awards, and at least in one case, even the Nobel Prize. This year's prize is essentially in the same field as in the first year in which the prize was awarded to Juan Maldacena and Michael Douglas. It so happens that Marek and I were the coordinators also in the selection procedure of the first laureate. So in some way, we are closing a circle. Secondly, it is the first time that we have an Israeli laureate of the prize in physics, Zohar. And thirdly, it is the first time we award the prize when Dr. Raymond Sackler is not with us. Raymond Sackler passed away last July. Dr. Sackler, his wife Beverly, and the Sackler's family, through their foundation, are champions of general support of excellence in higher education, science, and art throughout the world, and in particular in Israel and at Tel Aviv University. The Sackler's fingerprints are all over our university, and two of its leading faculties, the Faculty of Exact Sciences and the Faculty of Medicine, bear the family name. Over the years, many institutions, centers, chairs, and programs, including international cooperation programs and prizes that help putting our university strongly on the world map, were endowed by the Sackler Foundation. While serving years ago as director of the university, I had the privilege and honor of getting to know Raymond Sackler. We had many conversations about the importance of higher education and the uncompromised need to excel and lead in scientific research for the state of Israel. Raymond Sackler was a dedicated supporter and a friend who shared our views and visions. His legacy will live on. We have received a short letter from Jonathan and Richard Sackler, the sons of Raymond, which I would like to read aloud. Dear friends, we are grateful for the opportunity to congratulate Professor Zohar Kumargotsky and Pedro Vieira on being awarded the 2018 Raymond and Beverly Sackler International Prize in Physics. Their work in quantum field theory in non-perturbative regimes sets a new standard for scientific excellence and distinguishes them as leaders in their discipline. We also wish to thank the selection committee for completing its challenging task of choosing these individuals from a group of highly talented, Nina, please, Okay, let me read again. We also wish to thank the selection committee for completing its challenging task of choosing these individuals from a group of highly talented researchers. While the Sackler Prize has been awarded since 2000, this is the first time our father, Dr. Raymond Sackler, is not with us. Nevertheless, this is a joyous occasion because this year's prize fulfills a dream of his, a dream that inspired the establishment of this prize and guided almost everything he did. Throughout his blessed long life, Raymond Sackler encouraged and supported excellence in science. And he wished for that pursuit of excellence to endure, to extend beyond his life and benefit future generations. As we recognize these talented young scientists and their groundbreaking research, we also help to realize our father's dream. We see his work continue even after his death. This is in large part thanks to Tel Aviv University, which for nearly 50 years enabled our father to support the area about which he was most passionate: higher education, scientific research, patient care, and medical innovation. He saw this as the keys to a better world and the means by which humanity could reach its greatest potential. In partnership with Tel Aviv University, Raymond Sackler continues to help the best minds pursue these noble causes. He was proud to support higher education in Israel, for he recognized that this university played a critical role in the success and security of the state. He endeavored, in his own words, to keep Israel at the forefront of the international community of science and scholarship and to put Tel Aviv University on the world map. It is impossible to argue that any part of his vision remains unrealized, especially given that this year, for the first time, an Israeli scientist is one of the recipients of the Sackler Prize. Again, we congratulate this year's prize winners and wish them continued success. Jonathan and Richard Sackler. I would like now to call upon the rector of the university, who is also a member of the Sackler Faculty of Exact Sciences, Professor Yaron Oz, to address the audience and present the prize to our distinguished laureate. Yaron, please.
Okay, good morning. It's actually a real pleasure to do that. In particular, in general, we don't understand what is the type of research that the laureates do, and in this case, somehow we know something. I have to do two things. One, I have to give a certificate, and second, I have to give a check. Which one of them is more important, I'm not sure. We'll see. And so let me begin by just... Okay. After that, they will take a picture. I'm supposed to read that. This is to witness that on the 13th day of March 2018, the Raymond and Beverly Sackler Prize in the Physical Sciences for the year 2018 was presented in the field of quantum field theory, novel developments, to Professor Pedro Vieira, Perimeter Institute, Canada, and ICTP, Brazil, for his innovative work bringing the power of integrability to bear on a variety of observables in n equal to 4 supersymmetric Yang-Mills quantum field theory, as well as for developing a new S-matrix approach for constraining the amplitudes of massive quantum field theories, signed by Professor Joseph Klafter, the president, Professor Shimon Yankelevich, prize coordinator, and Professor Marek Karliner, both of them the coordinators from the School of Physics and Astronomy. Okay. I think good? Okay, please. Thank you. And one. Okay, and next. So first I will read and then we'll take a picture. Now in Hebrew, Zot Le'edut, this is to witness that on May 13th of March 2018, the Raymond and Beverly Sackler Prize in the Physical Sciences for the year 2018 was presented in the field of quantum field theory novel developments to Professor Zohar Komargotsky, Weizmann Institute of Science, Israel, and the Simon Center for Geometry and Physics, State University of New York, Stony Brook. For his broad and deep insights, which have shed remarkable light on many aspects of quantum field theory, including renormalization group flows, dualities and phase structure, conformal field theories, and effective field theories for broken supersymmetry and long strings, signed by Professor Joseph Klafter, President of Tel Aviv University, Professor Shimon Yankelevich, a prize coordinator, and Professor Marek Karliner, coordinator. Okay. Okay, I think that concludes my part. Thank you. I would like to invite Professor Marek Karliner, one of the prize coordinators, one of the two prize coordinators, please.
It's a great pleasure to introduce our laureates who will now give short presentations which are intended for the audience which which is here now. And for those of you who are interested, in the afternoon there will be more technical talks. For people who work in this field, there will be two theoretical seminars by Zohar and Pedro. So we will now have a presentation by Zohar Komargotsky, who obtained his undergraduate BSc degree at Tel Aviv University. I had the great honor and pleasure to be one of his undergraduate teachers. And I must say that already then it was clear that he was a singularity. And Zohar did his PhD at Weizmann Institute, and then he was a postdoc at the Institute for Advanced Study in Princeton. And he is now a professor at Weizmann Institute and simultaneously at the Simon Center for Geometry and Physics at the Stony Brook University in United States. He is a laureate. In addition to the prize that he had been awarded today, he is a laureate of the New Horizons Prize in Physics 2012 and the Gribov Medal of 2013. These are probably the three most important awards that are given specifically in the field of quantum field theory. Zohar is a really unique theoretical physicist capable of making fundamental contributions in very different fields, ranging from quantum field theory to string theory, from conceptual aspects of quantum chromodynamics, the theory of strong interactions, to physics beyond the standard model. And just in a few words, a quick scan of some of his most outstanding contributions. Early on, he discussed what happens when supersymmetry is broken. You know, supersymmetry is symmetry which is an extension of symmetries of the standard model. In such a case, there is a new massless particle appearing, which is a fermion, has spin 1/2. And Zohar constructed a new formalism for describing the interactions of this particle, and this formalism is extremely important in many fields, including supergravity. Then he discussed what happens, one of the important symmetries of nature is so-called conformal symmetry. And Zohar discussed in one of his papers, how is it possible to deform a theory which has a conformal symmetry in such a way that the conformal symmetry remains unbroken? And this paper gave rise to a lot of follow-up work. Probably his most famous work is work on understanding how a normalization group works in 4 dimensions. When you coarse-grain a theory, he and Adam Schwimmer proved that the renormalization group flow is irreversible. This is a result which had been known to be true in 2 dimensions for many, many years, proved by Zamolodchikov about 30 years ago. And for 30 years, the best minds in our field tried to prove an extension of this theorem to 4 dimensions, and this was the first time that a success occurred. So this is a remarkable paper. Then Zohar provided a new tool for analyzing strongly interacting systems. We always look in theoretical physics for limits where you can do things exactly and then you do perturbation around that limit. So in a paper of 2012, he showed that when particles have very large spin, you get a theory which is relatively easy to attack, and then you can expand from there. This is a method which is known in statistical mechanics, but in quantum field theory, it was a novelty, and it's very important. He then worked on the connection between 2 very important symmetries, the scale invariance and the conformal symmetry. This was a very delicate subject which confused many very good physicists, and probably Zohar's paper is the first one in which the issue was clarified completely. And most recently, Zohar, with other colleagues, has worked on discussing what happens in QCD-like theories when you switch on a term which breaks the CP invariance, and a new kind of scenarios appear there. There is a new kind of anomaly. This is very interesting, and it might lead to new understanding of quantum field theories in non-perturbative regime. And the theme that goes throughout Zohar's work is a clever interplay between using all possible tools that we know in quantum field theory in order to understand what quantum field theories do in non-perturbative regime. So I have spoken enough, and